Hello everyone. In this video, we are going to discuss Chapter 2 Polynomials, Exercise 2.1 and related concept. If you have not subscribed JJLC Learning Classes, please subscribe it so that next time whenever I will upload a new video, it will directly come in your inbox. We have the various topics to cover up in this video. We are going to recap some algebraic expressions and extension of the same to polynomials and related terms we will study. Then we have kinds of polynomials based on terms. So different types of polynomials we will get to know with respect to terms. Next we have degree of polynomial. We are going to talk about the degree of a polynomial. Then we will do NCERT exercise 2.1. So these are the topics which we are going to cover up today in this video. Next we have polynomials. How can we define polynomial? A polynomial is an algebraic expression Px of the form Px is equal to an x to the power m plus a n minus 1 x to the power n minus 1 and so on. This is the mathematical expression or way of writing an algebraic expression, and that is represented by the Px value. Here P stands for polynomial, X stands for the variable that is there in the given expressions. Here we have non-negative integer. The power of the variable must be non-negative integer here. That is what we understand. It should be a whole number. So we continue with further algebraic expressions which contains constant and variables, and it could be in monomial, binomial, or trinomial, as we have done in previous class. So an algebraic expression is the combination of constant and variables connected by all or some of the symbols by plus, minus, multiplication sign, division sign. And you can see the example 2a, that is a monomial, 5x minus 2y, that is a binomial, p square plus 3p cube plus q square, that is a quadratic polynomial, and etc. We can have the various examples. Now next we have the real number. Here an minus 1, all the coefficients of the variables we have here, the real number you can say, and these real numbers means it could be a rational or irrational value, that the coefficient of the variable in the polynomial. Next, non-negative integers means all the positive and numbers on the number line and 0, which means whole number. So the indices, or you can say exponents of the variable in the polynomial must be a whole number. That is what we understand from the definition. It cannot be a negative integer. If within the given algebraic expression the power of the variable is any negative number, that it means an integer, we can say that that is not a polynomial. For an algebraic expression to be a polynomial, it is must that the power exponent, or you call indices, that must be always a whole number. That's what we understand from the definition of the polynomial. Now we have types of polynomials here. Based on terms, we decide the different polynomials and then degree. Here we have the monomial. You can say monomial has the only one terms, and there is a 7, 8x, 7ab. These are the examples where we don't have any plus or minus sign here. As a 7p square q is as a single term. So here we have the multiplication sign between 4 and p square, and between q we have the multiplication sign, but this is as a whole a monomial. So we differentiate the terms based on plus and minus sign. In binomial, you can see here 4x minus 7, we have the negative sign in between, and we have plus sign in 2x plus 3. So that there are two different terms, 2x and 3 are the two different terms, and in between we have the plus. So terms are separated by plus and minus sign, not division and multiplication sign. If we have the division and multiplication sign in between, then it will be considered a single term. So you can understand from here 7 into x. Here we have the 7x. It's a monomial. It's not a binomial. But if we have 7 plus x, then we have a constant 7 added to a variable x. This is an example of binomial. Trinomial. In case of trinomial, we have three terms. You can see a 5x minus 3y plus 7 separated by minus and plus sign. Now degree. Based on the indices, or you can say power of the given variable, we decide the degree of the polynomial. In linear polynomial, we have the degree 1 because the power of the given variable in the polynomial remains 1. We can say here x is having the power 1 here. We can assume here 1 as the power of x, and in case of y also we can assume here y. It's understood here that we have the power 1. In quadratic polynomial, we have the power of the variable to be 2. So we can have the examples here on the slide now. Here we have 2x squared plus 3x minus 7. You can see that the x is raised to the power 2 and a is raised to the power 2 here. So these are example of quadratic polynomial where the highest power of the variable is 2 here. Next we have the cubic polynomial. So in case of cubic polynomial, we have the highest power of the variable to be 3. So here we have the examples: 8x cubed plus a cubed plus 2a square minus 3. These are the here we can say the powers having 3. Highest power within the given algebraic expression, that is 3 here. That's why it's a cubic polynomial. Now next, the degree of a non-zero constant polynomial is 0 always. So if we have a non-zero constant polynomial, the degree is always 0. If I say 5 is a polynomial or not? Yes, 5 is a polynomial. Why? Because 5 can be written as 5x to the power 0. It means we can say 5 into any number raised to the power 0 is 1. So 5 into 1, again it becomes 5. So 5 can be assumed as 5 into x to the power 0. So we say that 5 is a constant polynomial. So in case of a constant polynomial, we say the degree is 0. 0 itself is called the zero polynomial. That you need to understand. Now we have exercise 2.1, question number 1. Which of the following expressions are polynomials in one variable and which are not? State reasons for your answer. We see the first part here, 4x squared minus 3x plus 7. Here we have the indices. That means the x is raised to the power 2, and all the powers are positive values here. Here we have 1, here we have 2. So we say that this is a polynomial in one variable. In case of second part, y squared plus root 2, you can say here the y is raised to power 2, that is a whole number, so it's a polynomial. So it is a polynomial in one variable. Now next we have third part, in which we have 3 root 2 t root 2, then 3 t raised to the power 1 by 2, and then t under root 2. Here the exponent of the first term is half. You can see here root 2. Root 2 means root t, not 2. Root t we have. Root 2 we have here with multiplied with t. But in the first term we can say under root t. Under root t means we have t raised to the power 1 by 2. So here the power of t is a fraction, or you can say a rational number. That's not a positive value. That's not a whole number. So we say this is not a polynomial in one variable, because to become a polynomial, it is very important, it is mandatory to understand the powers and indices that must be a whole number. In fourth part, again we have y raised to the power minus 1. So we can say that here we have the power minus 1, that is a negative number, so it's not a polynomial. So next, x to the power 10, y to the power 3 plus t to the power 10. Here we don't have a polynomial in one variable. We have different powers, and you can say that x, y, t are the different polynomials. They are not in one variable because three different variable we have, but all the powers are here positive. So we say it's a polynomial. Write the coefficient of x square in each of the following, and we say that the first part, the x square, is not having any number by which it is multiplied here. So we assume x square is equal to 1. So x square is multiplied with 1. So x square into 1. So here we have the coefficient of x square to be 1. In case of second part, third part, we have -1 here because minus x square can be assumed as -1 multiplied with x square, positive x square. So it becomes minus x square. So you can assume here -1. So the coefficient will be -1 itself. Now in case of third part, you can see pi upon 2x square plus x. Here x square is being multiplied with pi upon 2. So we have pi upon 2 as the coefficient of x square. Fourth part, root 2x minus 1 we have, and we don't have x square in this polynomial. So we say the coefficient of x square is 0. Whenever we don't have such terms for which we are finding the coefficients, we write the coefficient to be 0. Now next we have question number 3. Give one example each of the following of a degree 35 and of a monomial of degree 100. So we can have various infinite number of such example of binomial where degree 35 and a monomial of degree 100 we can assume. You can see binomial of degree 35 may be taken as x to the power 35 minus 8. You can have y to the power 35 plus 20. So various examples you can consider by your own. Monomial of degree 100 may be taken as x to the power 100. It could be y to the power 100 as well. So you can take any variable. R to the power 100 you can consider. So there are various answers for this part. Now we have next question number 4. Write the degree of each of the following polynomial. So we are supposed to write the degrees of the polynomial from 1 to 4. The first part you can see 5x to the power 3 plus 4x square plus 7x. The highest power of the term is 5x to the power 3 and the exponent is 3 here. So we say the degree of this polynomial is 3. In second case, we have the second part here, the degree 2, highest power is 2, exponent is 2 here in case of minus y square. So this is what we can understand from the second part. Now third part, 5t under minus root 7. T has the exponent as 1. So we have the degree 1 in case of third part. Now in case of fourth part, we have the degree 0. Because this is a constant polynomial 3, and we know that in case of constant polynomial, that can be assumed as 3 into x to the power 0. So we have the degree 0. Now next question says classify the following as linear, quadratic and cubic polynomial. So here we have the first part, that is x square plus x. So the highest power of x square plus x is 2. That is what we have written here, and so it is a quadratic polynomial. So a polynomial with degree 2, we know that is a quadratic polynomial. Now second part, highest power is 3, so it is a cubic polynomial. And in case of third part, we have the highest power 2, so it's a quadratic polynomial. Y is raised to the power 2 here, so we say this is an example of quadratic polynomial. I hope you understood all these questions. Now classify the following as linear, quadratic and cubic. So here we have the highest power of x in 1, so linear polynomial. In the fourth part, the polynomial has the power 1. X has the power 1 here. We can assume x to the power 1. So this is the linear polynomial. In the second part, again we have the power 1 here. 3t to the power 1 can be assumed, so it's a linear polynomial. R square is quadratic polynomial, again power 2. The highest power is 2 here. Now in seventh part, we have the power 3, and that's why we say it's a cubic polynomial 7x to the power 3. Thank you. Please like, share, and subscribe.